Hello, ladies and gentlemen. This is Pre-Calc Lesson 40, the argument in mathematics, law of logs, and properties of inverse functions. So let's talk about the argument. Okay, we have three definitions. The first is the connection of statements, or statements or reasons. That are intended to establish or refute a given proposition. Definition 2 is the angle in polar form of complex numbers. And definition 3 is the input of a function. Okay, so we have the different argument of things. So an example would be if we are plugging in x into a function, then we have f of x, and the argument would be the x. Right? If we were plugging in x plus 2 into a function, the argument would be the x plus 2. Okay, now let's talk about logs. We need to remember that logs are exponents. Okay, so all of the rules of logarithms relates directly to the rule of exponents. So one rule, the log base b of mn, we can break this up into the log base b of m plus the log base b of n. Right? And we know this relates to exponents. If we have x to the a times x to the b, we write this as x to the a plus b. Right? We know that to be true of exponents, and that's actually where we get our property of logs, our multiplication property. You have to memorize this. We will be using this over and over and over and over and over in lots of different forms. So this is one of the rules. Put a 1 next to it. You have to memorize it. Now let's do an example with that rule. Okay, if we want to solve, we have the log base a of 4 plus the log base a of 6 equals the log base a of x plus 4. So I have 4 plus 6. I'm going to rewrite this as the log base a of 4 times 6 equals the log base a of x plus 4. Now if we have two logs of the same base equal to each other, I can set their arguments equal. So I can say 24 equals x plus 4, so x is 20. Okay, let's look at another property of logs. If you have the log base b of m over n, you can break it up into the log base b of m minus the log base b of n. So, our example with that, if we have the log base 4 of x plus 6 minus the log base 4 of x minus 1 equals the log base 4 of 5. If we have two logs of the same base being subtracted, I can rewrite this as x plus 6 over x minus 1 equals the log base 4 of 5. And if I have two logs of the same base that are equal, I can set their arguments equal. So x plus 6 over x minus 1 equals 5. And I cross multiply, so I get 5 times x minus 1 equals x plus 6. So 5x minus 5 is x plus 6. So 4x is 11, so x is 11 over 4. Now, make sure you have to check that your arguments, this is your argument, this is your argument, this is your argument, your arguments are positive. So if you get an x value that if you plugged it in would give you a negative argument, then that x value does not work. We count it as an extraneous solution. All right, let's do our third property of logs. If we have the log base b of m raised to the n, we bring the power in the front, giving me n times the log base b of m. So let's do an example. if we have 3 times the log base b of x equals the log base b of 8, I can rewrite this as the log base b of x cubed equals the log base b of 8. Two logs of the same base that are equal, I set their arguments equal, so x cubed equals 8, showing me that x equals 2. Okay, let's do another example. If I have the log base 12 of x equals 2/3 the log base 12 of 64, I can rewrite this so I get the log base 12 of x equals the log base 12 of 64 to the 2/3. Okay, so here I can get x equals 64 to the 2/3. Now I can rewrite this. X is 64 to the 1/3 squared. The cube root of 64 is 4, so I get x is 4 squared, so x is 16. So you need to memorize those 3 properties of logs. Now let's talk about inverse functions. Inverse functions, right, starts with, remember if we have f of g of x, we rewrite it as f of g of x, meaning the argument for f is g of x. That's what I'm plugging into f. Now, 2 functions are inverses if f of g of x equals x for all x in the domain of g, and g of f of x equals x for all x in the domain of f. Now, another key thing, the range of g needs to equal, by equal I mean be in the domain of f, and the range of f needs to be in domain of g. So if the domain of g was negative numbers, then the range of f needs to be in the negative numbers. Okay, so let's do this example. I want to show f and g are inverses. Too many s's. Inverses. When f of x equals 1/3 x minus 3 and g of x equals 3x plus 9. So I first need to find f of g of x. So I'm going to plug in g of x into f here. So I'll get 1/3 times 3x plus 9 minus 3. Well, 1/3 times 3 gives me x, plus 3 minus 3 gives me x. That's what we want. Now I need to find g of f of x, so I'm going to plug in f of x in the x for g. So I get 3 times 1/3 x minus 3 plus 9. 3 times 1/3 gives me x minus 9 plus 9 gives me x. So f and g are inverses. Now the domain of f and the domain of g and the ranges for both are all real numbers. So my domain and ranges for f and g match up. All right, let's do another example. I want to show that f of x and g of x are inverses. So I first need to find f of g of x, meaning I'm going to plug in g of x into f. So I'll have 1 over, here I'll get 3x plus 1 over x minus 3. So I need to simplify. 1 over 3x plus 1 minus 3x all over x. Well, 3x minus 3x goes away. So I have 1 over x, which is just x. Yay! Now I need to find g of f of x. So I'm going to plug in f of x everywhere there's an x and g. So I get 3 times 1 over x minus 3 plus 1 over x minus 3. All right, so here I'm going to simplify. I'll have 3 over x minus 3 plus 1 over 1 over x minus 3. Okay, I'm going to multiply by the reciprocal x minus 3 over 1 to cancel this out here on the top and the bottom. And if I multiply by x over 3 minus 1 here, it cancels, leaving me with 3 plus, here I'll have x minus 3 over 1. And 3 minus 3 just gives me x. Ta-da! So, remember, to show that two things are inverses, you have to show that f of g of x equals x and g of f of x equals x. Don't forget to memorize your properties of logs. I suggest you put it on that formula sheet you should have been making this whole year so far. But while you're doing that, I will stop recording so you can focus on memorizing those. Good luck on the rest of your homework.